of atomic model all started in 400 BC when Democritus created the first atomic model. Democritus' first atomic model, which is a round sphere with no electrons, protons, or neutrons. His contribution helped people with understanding the idea of an atom, and helped other scientists a further look into the science of the atom and its generic makeup. Still in the same timeline, in 400 BC, Aristotle developed a theory that was based on the four elements. However, the majority of Greeks who gave thought to the subject believed that the smallest unit that anything could be divided into was the element. Aristotle named four elements: fire, air, earth and water. He also believed that there were four qualities to these elements: dryness, hotness, coldness, and moistness. Later on December 3, 1803, John Dalton proposed his modern theory of the atom. He based it upon 5 factors, which includes that matter is made up of atoms that are indivisible and indestructible. All atoms of an element are identical. Atoms of different elements have different weights and different chemical properties. Also, that atoms of different elements combine in simple whole numbers to form compounds. Finally, Dalton proposed that atoms cannot be created or destroyed. When a compound decomposes, the atoms are recovered unchanged. In the year 1897, J.J. Thomson discovered the plum pudding model of the atom. J.J. Thomson, who discovered the electron in 1897, proposed the plum pudding model of the atom in 1904 before the discovery of the atomic nucleus in order to include the electron in the atomic model. In Thomson's model, the atom is composed of electrons, which Thomson still called corpuscles. Later on in 1911, Ernest Rutherford theorized that atoms have their positive charge concentrated in a very small nucleus. He pioneered the Rutherford model of the atom, with his discovery and interpretation of Rutherford scattering in his gold foil experiment. He performed the first artificially induced nuclear reaction in 1917 in experiments where nitrogen nuclei were bombarded with alpha particles. In the year 1913, Niels Bohr presented a picture of an atomic structure. He passed on to a study of the structure of atoms based on Rutherford's discovery of the atomic nucleus. This led him to the picture of his atom. In 1926, Erwin Schrödinger generated a mathematical model for the distribution of electrons in an atom. The solution to the Schrödinger equation led to quantum numbers which provide the address of the electrons in an atom. Erwin Schrödinger developed a powerful model of the atom in 1926. Schrödinger combined the equations for the behavior of waves with the de Broglie equation to generate a mathematical model for the distribution of electrons in an atom. In 1927, we had Werner Heisenberg. Here the foundations of quantum mechanics and the cloud model of the atom was laid. The uncertainty principle stated simplistically that the more precisely the position of an electron is determined, the less precisely the momentum, mass and velocity is known in this instant, and vice versa. In 1932, James Chadwick proved the existence of neutrons. He heard of a new method of detecting particles emitted by radioactive elements developed by Irene Joliot-Curie. The essential nature of the atomic nucleus was established with the discovery of the neutron by James Chadwick in 1932 and the determination that it was a new elementary particle, distinct from the proton. The discovery of fission led to the creation of both nuclear power and weapons by the end of World War II. In the 21st century, we have the modern atomic theory. The modern atomic theory states that atoms of one element are the same, while atoms of different elements are different. Atoms of the same element, that is atoms with the same number of protons with different numbers of neutrons, are called isotopes. Most naturally occurring elements exist as isotopes. Finally, we have gotten to the end of this video. If you found value in this video,